Hello everyone, thanks for coming for today's presentation. My name is Amit Satur and here's my colleague Christoph Streubert. So we are both going to present to you how we see from SAP perspective the big data use cases and applications evolving in this marketplace. So we have now new products that we announced recently. That's SAP Vora 1.4 and it has some significant new functionality, so we'll cover that in this presentation. We'll also cover some of the early use cases and production successes that we have had. And then we'll walk you through also some of the new offerings we have, which is big data as a service in the cloud, and how you can build new applications and do transformations using it. So going into the first about like the presentations, we try to make it as entertaining as possible, and that's I guess Christoph or me after last night's beer hall visit. So I think we're still recovering a little bit from the jet lag. So one of the things that what we have seen is that there are variety of use cases, right? And they're all powerful. One of the good things about big data is always you can find interesting use cases about it. But last year, I think they did a survey on, not survey, they basically used big data to understand which one was the most popular place for chocolates on Valentine's Day. And I don't think anybody could guess here, but it was one of the municipality in Turkey. That's where you found most people interested in chocolates. So you find these use cases that you can never imagine what data can tell you, and all your assumptions go out of the window. So one of the interesting use cases we came across was for smart meter reading. There are a lot of smart meters that are being installed, but the data that they collect about petabytes of data a week. And the biggest challenge with that is that you have to store that for 10 years for regulatory compliance, and also to be able to get analysis out of it. Because if you can't store that data effectively, it's very difficult to make any analysis of that data. So with Vora, what we have been able to do, along with HANA, is to allow them to store that almost like petabytes of data effectively, some of that in the operational systems, and some of that into more of an Hadoop cold storage. And what we have done with that is we have provided computing engines on both platforms. And that's one of the unique things that we have been able to do is that for this company, we have HANA platform that provides them the computing processing on it, but also on Hadoop platform itself, you have in-memory computing resources. So by doing processing on both ends, it was much easier for them to actually meet the requirement for regulatory compliance as well as for operational systems. So with this one, they have been able to store large amounts of petabytes of data onto HDFS processed by Vora. And within Vora, we have multiple processing engines. We have Graph, we have time series. We also have doc store, because a lot of that data ends up becoming in the large files that you really cannot structure it in a relational store. At the same time, doing dynamic tiering with the HANA side also store operational data. So very powerful use case, because what we see is a lot of folks collect data in IoT from IoT systems. You know that certain sensor is going to heat up or going to fail, but many times the challenge is once you know that about that sensor using in a Hadoop, you want to replace that sensor. Well, for that, you need to go into the product catalog and find out what is the sensor part number, what is the reorder level, when is the technician going to come and replace it, when he replaces that, what other components he needs to replace along with it. So it ends up becoming a lot more than just getting an insight from an IoT sensor that this sensor is not behaving properly. And that's the reason architectures like that we have here with smart meters are very compelling. Going into the next one is this is the agricultural. Last year at Spark Summit in Brussels, there was a very interesting use cases about agricultural scenario. I'm not sure how many of you were at Spark Summit last year. So the use case was mostly actually going into a lot of the agricultural waste and finding out how can you effectively get better yield. And it's kind of amazing how much advancement have been done in agriculture using big data. And we have been able to help a lot of our customers doing that, because the data that gets collected for a lot of these large fields ends up becoming big. And many times in the past, they did not have resources to actually effectively compute with this data. And what we have done is that allow them to store these large volumes of data they're collecting from their sensors, like water sensors, yields from the crops, fertilizers they're using. Because in many times they are putting fertilizers, sometimes they're over-fertilizing it and getting lower yield. but a lot of this data is not available for them to quick analysis. So by analyzing this data in their systems, we have been able to provide them what is the optimal yield that they can get from this crop. And this is one of our customer use cases where it's more about sugar production, and it is very sensitive to the temperature, water, and fertilizer usage. And every year, as much as we think that we have fixed seasons, from the crop perspective, every year is unique. And based on how much rain has that happened so far and how much is going to be happening in the future, that really affects what kind of fertilizer production they're going to provide for that crop. And that's one thing we have done with our Vora offering as well as with HANA offering. So what is Vora? If you go into the way we see the market is evolving, it's about 10-year anniversary for Hadoop now. Hadoop has been there for over 10 years. The first phase was more about storage. We had high volume data, we had high velocity data, and the biggest challenge we had is like, how do we store it, right? So then we started with Hadoop as a cheap storage. Once that was done and we handled that problem, the next one was, yes, we have stored that data. How do we process this data? And that's where the whole computation engines came into play. And especially with SAP, we have been doing in-memory computing for as long as Hadoop has been out, almost for 10 years with HANA. And we have a lot of experience in terms of different processing engines that it needs from business perspective. Many times it is underestimated what it takes to do currency conversions on a global basis, the temperature conversions, the data hierarchies. So a lot of those specialized engines that we have in in-memory computing, we have been able to bring to Hadoop environment. So right now, if you look at your own Hadoop, you look at your Spark environment, we can easily put Vora engines on it and provide you better business analysis for it. The next phase that we see in this journey is actually going into transformation. Because you can analyze this data, but unless that data is part of a certain process, as I mentioned on IoT sensor devices, unless you can trigger a maintenance work order, that analysis is of no use. So you have the analytics side consumption as well as the business process consumption, and that's where we are going into the next phase about using that computations that are done with Hadoop, and now how do we change the business process? And there are about two different worlds that we see in it. One world is you have data warehouse, which we created a long time ago, and how can we extend that data warehouse itself, the same metadata, same structures with better Hadoop data? Right? We are basically using the same structure, but better data insights into it. And the next world is you have your big data lakes, and how do you use context of your relational data to get better insights into the Hadoop data itself? Because many times, like, you will find social data that you get, but the problem is, like, to understand that social data, that people like this purple type product, well, you have thousands of product SKUs on your product catalog. Without understanding those SKUs and which product has which parameters, many times the social data is useless. Or you really cannot analyze that data or filter that, because it will give you a cluster diagram, but unless you click into that cluster, and if you don't know anything about that product, you will not be able to analyze and get to the right level saying that this product actually has better demand from the social sides. Right? For that, we are providing the transformation solutions that you see now from our roadmaps. So as I mentioned, what is Vora? We have taken our in-memory computing expertise that we developed with HANA with different processing engines, and we have put it on Hadoop. So you have a completely new in-memory computing engine framework on a Hadoop stack itself. Our main goal here was not to create every engine, but the engine that is needed for a specific use case. Because what we realized is that, like, to go into production, having just a super duper stack wasn't useful, because many times there was an architecture and stack had a lot of more components. And it was created saying that we want to create a platform. The challenge with platform is it didn't meet any specific need of a use case, and many times it was too cumbersome to move into production when you said that I just want to solve customer 360 for telco. Well, do I really need all the other processing engines that I've built into the stack? Answer is no, because the more the engines, more product lifecycle issues you're going to have, and tougher it is to move into production. So what we have done with Vora is right now provide you the three main engines like SQL and OLAP, time series, Docstore, and Graph. So with those engines, you can actually provide a better environment for a lot of use cases that you need. The main thing what we have realized is the challenges with data modeling, right? When we started with RDBMS, we already started with a model. So it was much easier to capture the data to an existing model. When you get into Hadoop world, there is no model. And one of the beauty of it is that you get to see all the data to actually tell you what the model should be. So that's the reason the modeler is quite important. And we have all of this integrated so that when you're doing modeling, you understand different engines that are going to use that data set. Then what we also did was this to memory accelerator, because in any in-memory computing, this is the key piece. You want to persist your data because once you transform, you don't want to lose it. But at the same time, you need to do it fast, so that when you loaded the data and you have a new time series data coming in, it's not like you're analyzing the older data. So we added the disk to memory accelerator. We also did a distributed transaction log. And the thing is that when you go through transformation, you will go through multiple transformation for data cleansing, data quality, master data creation. You want to persist each state so that you're not starting all over again, right? Because although Hadoop clusters are pretty fast and efficient, the data set is big too. So every time you're starting with this, all of data to be transformed is a lot of overhead. So what you're trying to do is with the log, you can actually go through a previous state, like you see that in Spark 2, that you can go to a specific state and actually bring that data set back in that is already transformed, right? So that's basically what we are doing with transaction log. And it works with your Spark platform, Hortonworks data platform all together, so that you already started with your Hadoop and Spark environment. You basically add Vora to it, and you get that additional processing power or computation that you need for business purposes. So one of the things what we realize, and there is like this whole unstructured to structured process that is happening, right? Because initially what we were doing was we had a data warehouse and we could easily do OLAP cubes on it. Now, two things have happened. We are taking some of the data warehousing data and putting into data lakes, as well as we are getting new data and putting into data lakes. Now, when you look at that data, the OLAP modeling becomes extremely difficult, right? Because you're not starting with the model itself, and when you're trying to do cube analysis or star analysis, it is very challenging. So we provided you an OLAP modeler into it so that you can get a 360-degree view of all your models, graphical user interface. So you're not trying to do a command line queries to understand how you're going to look at this data. Because half the challenge is actually understanding the data, what it is. And many times with HDFS with flat file, that ends up becoming a bigger task before you can get into some kind of transformations or quality management with that data. Going to the next one is time series. Here, what we have provided you is actually a very efficient way of doing it in memory. There are a lot of time series modules available in the market, but when we look at the data for time series, we're looking at a lot of the business data that is coming in for you for transportation, for logistics, and things like that, and visualize that data so you can understand the correlation. Any kind of operational research issue or problems that you're going to see in the real business world is going to need time series data analysis for you. The next one is the graph engine. I think this is probably the most innovative things that I've seen in my computer science career and most complex one, because graph analysis is very difficult. And right now, if you look at online, like one person likes this, and then so you should like other things. It is all graph based. So we are gone. I mean, the next step from relational databases is into graph analysis. And it's very complex. And we have been able to provide you with those scenarios as well so that you can do better correlation. Because when we go to Hadoop, the beauty of it is that you are not restricted by the relationships that we already had before. You can discover new relationships. And the best way to discover these relationships is actually through graph processing. So you can go and do a SQL and OLAP analysis, which is more structured, but you also can do graph analysis, which is much more powerful. The next one is with Hadoop, we want to store all the data, right? So it becomes challenging when you get a document that is not structured to your metadata. And we have provided you a doc store right into Hadoop for processing, because we think it's the most important component right there in terms of the storage. Because many times, like the data that you will get, not more on the IoT scenario, but in social scenarios and also into more R&D scenarios, you're going to get a lot of different data sets that actually meet with this requirement, like image files, audio files, right? So how do you store that? So we have a document store itself in the engine so that you can process it all together. So as you can see, our main goal here is to provide an architecture where you can combine these engines without actually having to do integration by yourself, taking a different components. And this is one of our new solutions. What we realize is that as we have to make this Hadoop go into production very quickly for businesses to see value rapidly, what people were doing was there were a lot of time getting spent on actually just getting Hadoop started. And there is some of the skills issue as well as some of the way the technology is still after 10 years, because it's a complex technology. We tried with clusters a lot, and doing any kind of cluster computing, whether it's a Hadoop cluster or transaction processing cluster, is actually exponentially harder problem. So what we have right now is that to address these issues that we saw going from initial setup to actually a production, we are now have big data as a service from SAP that you can use. It's a cloud, and you can pretty much have a full service where all you need is ask for procurement of Hadoop, and we'll take care of everything of infrastructure, software, giving you the report. So we'll run it fully for you. So for folks who want to get started right away, this is a great solution.
Yeah,
and
that's pretty much the setup, how it looks like, right? The components and the capabilities and the disciplines that are combined and offered in there. So, and even though I'm actually originally from Munich, I'll continue in English. Just wanted to talk a little bit about architecture here, because Amit already touched on a couple of items I think that are very important, because we see it in the industry and with our customers that we have really two different camps within the organization. There are the Hadoop guys and big data guys, and that there are the SAP guys, traditional IT. And it's quite a challenge to make them work together. And specifically the time series engine, together with the connection to HANA, provides a capability that, for example, manufacturing companies in IoT use cases really need. You want to analyze sensors, you want to analyze sensor data, but you also want to correlate it to information that is important about creating a purchase order or identifying a specific component in the value chain of manufacturing. SAP Vora is really designed to break the barrier between these two camps, and that's why I like this picture of suits versus hoodies. It's just a different kind of way of working, a different kind of embracing tools. And Vora really attempts to bridge the gap here between these two approaches to data management. When you talk to a lot of SAP folks, and the way Hadoop is often used in the world of SAP, where applications that run on top of HANA, be it S4 or BW, need larger data sets and want to be more cost-effective about that. So in this sense, SAP Vora and Hadoop is used to dislodge larger amounts of data at a cheaper rate, where then the structures, what also Amit referred to, structures and schemas are defined by the application running on top of the SAP applications. So the extension of these schemas and the structure also occurs then on the Hadoop side. So there's not much on the Hadoop side that is utilized other than it's viewed as historical data, larger data sets, colder data. And we already indicated that SAP Vora runs on Hadoop Spark, right? Either on-premise, for example, with Hortonworks HDP, or we have the Altiscale, the SAP Cloud Platform Big Data Services, also available in the cloud. In fact, this month we opened the data center also here in Germany. However, the Hadoop Spark-centric view, where the data really comes from the different data sources from the bottom, it's not where the structure is enforced or the schema is enforced based on cubes. Is she talking to you?
No, I started.
That's okay. Where the structure doesn't exist at the beginning, right? You have a large variety of different data types coming in your HDFS environment. And you have the ability now with Vora also to process data in the ways and with the engines that also Amit already described. Now you have the ability not just to use SAP visualization tools, but pretty much any JDBC connector via the Spark Thrift server. We have tested Lumira and Tableau, but there's nothing that stops you from using also Qlik or Zoom Data or D3 to access Spark and to utilize the information in Vora to do visualizations. In this correlation now, it's becoming more interesting to have larger data sets run run your workload on top of the data sets that are relevant to your business process. So often you want to run something on Spark, you want to offer capabilities to your data scientists and the inclusion of SAP data. Now, if you would have to replicate SAP data or extract SAP data into HDFS, the moment it arrives there, it's already outdated and not relevant to your analysis. Vora also allows you to create a virtual table on the Vora side, for example, and pull in real-time data out of HANA that now can also be processed on the Hadoop side. That's very interesting for data scientists who also want to include SAP data. When we talk about, for example, the unification of these different engines that Vora delivers, and we compare that to what something a customer would have to do, who wants to deploy, for example, graph capabilities or a time series or a JSON document store, or even have to create OLAP functions, right? You would have to utilize quite possibly different tools from different vendors that have their own infrastructure, which is really hard to manage SLAs around that, not only within one data center, also maybe for disaster recovery purposes. And also from a data access method, each of these tools, they have their own SQL browser or a SQL editor or a shell script editor. And that's really hard to do and create a data model across these different data types or engines and make them available to a business process or to an application. It can get really complicated also to manage security across these various solutions, and federation is virtually impossible. Or you need additional tools to make it possible, right? And that's really, obviously, Vora to the rescue. SAP Vora has all these components already included, integrated engines that run on your existing Spark Hadoop infrastructure. That means you don't need a Neo4j for Graph, for example. You don't necessarily need MongoDB for document store. We're not trying to be the best Graph or the best document store in the world. We're not competing with these. But if you happen to have all these use cases under one umbrella, you don't need a specific infrastructure for each of these data types. You can all manage them under one umbrella. We talked about accelerator and transaction log already, which, by the way, is also really important. If you have, in a traditional Spark environment, you need Hive to persist your models. Vora has the ability to persist models natively. So that's also something interesting about Vora. In regards to the architecture, you'll find a lot more information and a lot more detail also online. We'll have, at the end of the presentation, also a few URLs that should probably help. But in essence, we have, from an architecture perspective, we include our own modeling engine that does the OLAP capabilities. We have the ability to pull data in from HDFS S3 that can be in the form of ORC files, Parquet, or CSV files. The idea is that we combine multiple engines, as Amit already described, right? We have on the number 2 in that area, we have that framework of multiple engines that can run independently, all of these engines on one node or individual engines on multiple nodes. Vora runs on the same Hadoop Spark nodes that you already use. So Vora doesn't require its own environment, its own infrastructure, which is also really important because you want to have the processing engine close to where the data is. The D-log, Amit already touched on that. We leverage the Spark SQL on the right side, number 3 in that area. And I know this is not the best picture. We actually have online on the URL that I'm also sharing with you then later. We have an architecture development guide that goes into a lot more detail. For those of us who like to geek themselves out, you can go into the details here. But what's important, and we already mentioned that, is the Thrift server via Spark allows you to utilize UI tools that can be from SAP, like Lumira, or also business objects, but also other tools like Tableau, Zoom Data, or Click. The Vora Manager, from a UI perspective, if you manage the components of Vora, the various processes that run on the Hadoop nodes, for example, we have the Vora catalog, disk, D-log processes. If you do a ps-ef and grep for Vora, you see actually these processes. We have individual fields and tablets here from them for the processes in such a UI also available. And for those of you who are used to work Ambari as a tool to manage your cluster, this is, for example, how Vora manifests and looks within the Ambari framework. So you have Ambari as the cluster management tool. and the Vora cluster manager for the Vora specific components. And they seamlessly integrate, right? That's important. We have some, we're pretty proud about version 1.3 specifically that became GA in November and December of 15 last year. We just 2 weeks ago came out with version 1.4, so we're trying to innovate as quick as possible. We realize that's important. And so in some of these areas that specifically that we delivered with 1.3 new functions, the improved Vora core and additional stability and enhancements. The big deal that Amit went in detail already are the engines, with the 4 engines that we initially delivered with 1.3, disk, graph, dock, and time series, right? The usability of the Vora modeler, which is a tool that's really, it's nice for business analysts who are not familiar with notebooks or don't understand Scala or R or Python. They have the ability to use the Vora modeler. That's a familiar tool to model data, to create tables out of files in HDFS, and also correlate them with data in HANA. So it basically offers Hadoop data to a wider variety of people in your enterprise and increases the leverage of data. That's why we also say, right, it's ready for production, and it helps actually get things up and running. The native HANA integration, we used to use a different process. Now there is a Vora ODBC. It's a native HANA integration between HANA and Vora. And I already mentioned that Vora is really the only tool that allows a bidirectional data integration towards HANA and also from HANA. With 1.4, that just came out a couple of weeks ago, we actually changed the product name. That was very confusing to a lot of people. It used to be called SAP HANA Vora. So people thought, so you need HANA with it? Is it an extension? Is it a plugin? What is it? Well, it's by itself. It's SAP Vora, right? And that's that. We have a much simpler installation package. So installation is very simple. We have now also, every version supports newer versions of Hadoop platforms. In this case, HTTP 2.5. We're sticking with Spark 1.6 for now. We have already also included the next generation OLAP engine that allows our own native distribution technology, not only among SAP Vora, but also with HANA at a later point in time. We included some additional functions for existing engines, for example, for the JSON document store, some additional semantics and syntax options. We've included Avro support and also a data preview. For example, if you build models from data in Vora, you don't necessarily have a visualization tool already available. So just to see if your queries and if your models yield the desired results, there's a data preview that allows you a little bit of visualization in the graph and time series area, for example, outside of a visualization tool that you may or not use. We have also online available a few very interesting tools for you to experience Vora on your own time. We call them value accelerators. They're, for example, for telco and the telco industry, a customer 360 analysis. It's a pure Vora use case utilizing some data that a telco customer or a telco organization would use to increase higher yield or customer satisfaction about their existing customers. So it's a customer 360 use case. We'll share with you the URL where you can find these. And they help you basically get faster to a result and demonstrate value to your organization. Because we realize, and I have been also a customer for a very long time, I've been in the business of having to not only test new technology and believing in it, but also having to deliver value to my stakeholders in the executive field very quickly. And these value accelerators, they allow you, they're sort of scripts, cookbooks to success that allow you to implement something in a fast and easy fashion and to just demonstrate value along the way for you to explore also some more complex scenarios. How you can start it, right? These value accelerators is one point or one ability. You can, of course, you can download your own developer version of Vora. It's available for download, install locally. You can run that on your laptop. We have a developer version also available in the AWS cloud. We also just last week made Vora available productively in AWS. And this is probably the most important. If you don't remember any of the URLs, This QR code brings you to the bottom URL, helpful links for Vora. It's one page where you have all the links available. They're inclusive of, for example, of the help that goes into more of the development guide, the installation, the release notes, things of that nature, administrative guide. We have also included the test drives, right? The Telco 360. We have one for a time series specifically, also for retail. Where the developer section is, where you can find some earlier version of Vora code on GitHub. And then another URL that I find extremely useful, it's also linked in here. We have a team that use basically YouTube as a medium to demonstrate and document how to processes. So Vora installation, configuration, data integration with HANA, they're like 10, 15-minute snapshots, and they're in succession. It's like a series. That's the SAP HANA Academy. And they also made Vora 1.3 videos available, about 18 or 20 of these short videos. They show you in detail how to configure it, how to administer it, and gives you a little bit more of a sort of a classroom-style experience without you having to go and spend the time in a classroom. So I find these really very useful. What else do we have? Thank you very much. And maybe any questions?
Yes, go ahead.
With the installation package, so with Vora 1.4, we don't have to install a Vora client on every node. So we have just one installation package going on every node?
No, yes, exactly. You have to install it on each node. That's correct. Yeah, yeah. And Vora assumes that you have Hadoop and Spark already installed, and a bar you need as well for the cluster management. Yep.
And which Spark version is?
161. Yes. Also, that's also a good question. We have a product availability matrix that's documented publicly as well. That's also in these helpful links. It's a PDF that we make available and update with every new version. It spells out which Vora version supports which Hadoop operating system and Spark version. Yes? Yeah, sorry.
Okay,
yeah.
What about the current status of this big data hub? I think you currently in developing it, and I saw some promising things regarding Altiscale. Personally, I think it's a kind of Hadoop distribution, bringing especially beneficial things for SAP BW customers, bringing Hadoop together with BW, and also orchestrating it, monitoring things. I think that would be very helpful. Probably you could give some insights on this current.
So thanks for the question. You ask on you touch on a few very interesting components. One, the Altiscale component, right? Amit actually already described that. It's the SAP Cloud Platform Big Data Services. That's the name we came up with. Instead of Altiscale, that's what we call it. But these guys, they have figured out how to do Hadoop as a service for a very long time, right? They have been doing this. Remy Stoddard, the founder of the company, came from MIT, has done Hadoop at Yahoo 10 years ago. So he has seen a lot how to do things right and how to do things not right. Right? So they have created a stack for inclusive of hardware, modified kernel, actually their own operating system, Apache Hadoop, Apache Spark, and a few other components. It's a defined stack that these guys also manage, and not only make it available, but also keep it up to date. And that's really the challenge here, right? So they make capacity basically available with 2 data centers in the US, and as of this month, also a data center in Germany. So for customers who, where the correlation of vicinity from a data center perspective doesn't matter, you can use it from anywhere in the world. But if data matters and it has to be close to you or within your country because of requirements, then Germany definitely has also a data center available right now. And the team is taking on productive workloads. We have a ton of customers already that are running on Altiscale. And you can also use Vora on Altiscale. However, we want to work closely with you. It's also, we have documented that on the product availability matrix. So we want to do an early adopter care program because Vora is also new to the Altiscale team, right? But that compatibility or that combination is already available. The second topic that you touched on, for example, for BW customers, right? This whole OLAP capability in Vora specifically. So utilizing cubes, for example, extending cubes out of BW also in the Hadoop world, that capability of Vora is very important and comes into play in that sense. Data Hub is something that you probably hear a little more during the Sapphire timeframe. Is there anything that you want to add about Data Hub specifically?
No, I think, the Data Hub is still in the early adopter stage in terms of the beta customers and all. So we'll have more information about it later on. But I think you're right. I mean, you looked at our strategy about transformation. How can we extend what the current environment is into the new one? But yeah, I mean, at this point, we're not talking much about Data Hub in general market. Yeah, go ahead.
You mentioned that you're executing graph queries on top of SQL. My question would be whether you use graph frames and whether you have adapted the thrift server to support motif queries, or how does it work?
So motif queries are not supported at this time. It's actually the other way around. So Graph runs by itself and separately from SQL. However, you can utilize SQL against the Graph data, inclusive also of the other engines, right? And as I mentioned earlier, we're not trying to be better than Neo4j, clearly, right? But if you have basic Graph requirements to discover and analyze relationships, then that's a valid use case. Now, we're happy to go into more detail with you offline about the features that Graph really includes in more detail.
But that also means it's a separate process, so it's not
yes.
timescale or something.
Well, it is, no, that's correct. So it doesn't take advantage of Spark, it's our own processing engine, but the rest of Vora integrates with Spark, right? Yes, sure. Any other questions? We're doing on time. We have 5 more minutes. Is that right? Yeah. All right. Any other questions? Awesome. Thank you very much.
Give you 5 minutes back. Thank you.